Welcome back. So now we're on the point of creating our repositories, and what we'll be implementing is a development pattern, really. So let me just give some background as to why we need to go through that. When we're doing our work with our API, it's easy enough to just write the queries using Entity Framework, Core, and Link, and we just write it, especially like when they have two tables contending with, which are country and hotel. But what happens when we have 8, 9, 10, 20 tables? It becomes kind of tedious to try and write queries every time we have a table, and then that's going to lead to repetition. And then if we have the same query multiple places, then that's a maintenance nightmare, really. So that's why we're going to be implementing a pattern, and we'll be using the generic repository pattern alongside the unit of work pattern to kind of create a container to define basic functionality that will be shared across all our tables and all our database operations in our project. So to get this started, I'm going to create two new folders. One will be called I repository, and the other one will be called repository, right? So we have I repository, and that's going to be a capital I. And then we're going to have another one that I'm just going to call repository. So there's a concept called separation of concerns, where you want to make sure that every file knows that it is doing one thing. So that's why we made sure to define two different class files for this. We're going to define some amount of individual classes along the way, but then we want to make sure that certain things are generic and we're not repeating certain things, right? So in our I repository, we're going to create an interface. So I'm going to create a class because that's just quick, but I'm going to call it I generic repository, and go ahead and click add. And I'm just going to change this out to interface. So if you chose interface, that will be fine. The only thing is that you have to remember to put on public, right? So that's the only reason I really choose class, because I've forgotten to put on public in the past, and I couldn't understand why I was getting the error I was getting. So that's my little fail-safe based on my experience. So what we're going to do is make this generic repository take a generic parameter in the form of T, where T is going to be a class. All right. So when we talk about generics, this T just says, well, I'm prepared to take any type of class that you send my way, and that helps us in creating those base operations for different situations with different class types. All right. So the first one that we're going to create is a function called get, or well, get all, right? So I'm going to say task I list of type T get all, right? And then I'm going to be defining certain things. So let me just explain exactly what is going on in this function header. So task, when we're dealing with asynchronous programming, we have to use tasks. If you're getting an error, it's probably because you don't have that library that I've highlighted there, at which point, you just do control dot and go ahead and include the using statement. So task I list of type T, once again, generic, and the function name is get all. So get all has a parameter for which I'm going to include the missing reference, which is of type expression function and expression, and we're making it an optional parameter. It's also going to take an iQueryable of type T, I ordered queryable, right? So you can just rewrite that how I have it, and order by, that's also optional, and then we have the ability to include if we need to. All right. Then I'm going to have a follow-up function for get. So task T get. So this one is going to get a list. This one is just getting one, right? So that's why it's task T, and this one is task I list. So this one is just going to get one record, and it's taking the same expression parameter, and it's going to have the include. So when we're fleshing out the actual function, then you'll understand what the parameters really stand for. We're going to have similar functions for our CRUD operations. So I'm going to have task, insert, T, entity. So this is going to be the one to create. We're going to have insert range. So I like to keep this one nearby because sometimes you have bulk operations. And instead of calling this multiple times, you could just define one that takes a list and it just does the rest anyway. We have delete, and I also have delete range. All right. And update. I don't like doing the update range really, but we have the update. So notice that the task, the delete is task. All of these are tasks, but these two are void operations. All right. So that is it for our generic repository. So once again, this is being defined as like a base catch-all, no matter what the data type. If we introduce 5 more tables and accompanying domain classes, we don't really have to change much here because these functions will be defined to handle any other table or domain class that gets thrown at it. So now that we have the interface, I'm going to go ahead and create the concrete class. So I'm going to go over to repository, add class, and this time it's an actual class, and I'm calling it generic repository. So I have generic repository, and now I have just generic repository. And generic repository is going to take the same generic T, but it's also going to inherit from generic repository, where T is a class. So I'm just going to go ahead and include the missing reference right there. And then it's going to complain now, because once we're inheriting, we have to make sure we implement. So I'm just going to go ahead and implement the interface, and then it generates all of those method stubs for me also kindly. So let us flesh out exactly what we need here. So we're going to have to do some amount of dependency injection. So I've mentioned that if I have before, I haven't mentioned it much, but dependency injection is basically the concept by which whatever we loaded up in the startup is now available application-wide. So we don't need to instantiate every time that we need it. All we do is make reference to the already existing object because it was defined in our startup, right? So more contextually, our connection or our bridge to the database, we can now just get a copy of that to use in our file here instead of trying to create a whole new bridge or a whole new instance of this bridge. We can just leverage the one that exists as a result of it being included in the startup procedure. All right. That's in a nutshell what dependency injection really helps us to do. So what we're going to do is define a private read only. It's private, it's read only because we don't need to make any modifications to it. And it's going to be an instance of database context. All right, include any missing references. There we go. Private read only, and I'm just going to call it underscore context. All right, and then similarly, I'll just duplicate this line because I want the private and read only. I want DB set. Remember DB set coming over from the same database context, and it's going to be defined for a generic. So I'll just go ahead and include the missing reference there also. DB set of type T, and I'm going to call this one DB. Now, these are defined for this class. However, dependency injection now will require me to create a constructor, and it's going to take a parameter of type database context, and I'm going to change the name. So the private one has an underscore, this one does not. And then having taken that parameter, it's now accessing the one or the copy from the startup procedure. So for my local use, I'm going to initialize my current context that I have as my private read only to be the same value as the one being injected in. So that's pretty much dependency injection. In case that was a mystery to you up until now, that is how it basically works. There are other nuances to it, but for now, it doesn't need to get much more complicated than that. So the next one is underscore db is going to be equal to context. Now that I've initialized context, I can say context, give me a set of whatever t is. And remember that at this point, t needs to basically correspond with something that has been outlined in our db set in our database context. All right. So that is why I can confidently say, go to the context file and give me a set of whatever this is, because the context file should know about it by the time we're building this repository. So now that we have that part done, let us go on to our implementation. So let's do the delete, which is fairly easy. All I'm going to say is var entity is equal to, and then I'll await. So because we're doing asynchronous programming, you have to await. So I have task here, but what I'm missing is the async keyword before it. Right? Anytime you have a task that you're going to be using await, you have to have async. All right. Notice when you click one, the other one gets highlighted. They go hand in hand. All right. So we say await underscore db dot find, and I'm just going to find async. So in .NET Core, in Entity Framework Core, for almost every operation, you have a corresponding async operation. So at this point, it's there, use it. And if you're using async, you have to precede it with await. And by extension, the method in which this await keyword is being used needs to have async on the method stub. So it's not in the interface. But in the definition, you have to have that. As you write it more and more, you'll get the hang of it. So we'll find async and we'll pass in the ID for the record that we want to find. And then we'll say db.remove. And we're removing the entity that has been found with that ID. And that's it for delete. Now, delete range is pretty much one line. It's just going to be db.remove range. So we have a list of entities. So I'm going to say db.remove range, and remove range says, well, give me the list of entities. Well, there's your list of entities, just remove them. Right? That's it for the remove range. So I'm going to go ahead and kind of go through the easier ones. So insert is easy, insert range is easy, and update is easy. And then we'll go back to the get and the get all, because those can get a bit more complicated. So I'm just going to prepend each task in the method header with the keyword async. That one is void, so I don't need async there, just to make sure that I don't run into any difficulties later on. All right, so for insert, that one is fairly simple. All we're going to say is await db.addAsync, and we add the entity. Whatever came over as data, add it. That's all we need to do, right? And then similarly for the insert range, all we're going to do is db.addRange async. So this one has an async. Notice remove range did not have an async. Right, so add range async and the list of entities that you got to add. And then for our update, we have a two-part operation. One, I'm going to attach the entity to the DB. So in other words, when the data comes over, it might not be attached, or it might be an object that exists in memory with no direct connection to the database at that point in time. So attach means pay attention to this and check if you have it already, check if there's any difference between it and what you have in the database, because we're about to do an update, right? So then it starts tracking to see that, okay, there are certain fields that are different. So these are two different, let's say, records, right? And then the next line would say context.entry, and then we reference entity dot state is equal to modified. So once we tell it that, okay, it has been modified, then it will know that, okay, I need to do an update to it. So let's go up to our get. So get is actually easier to do than get all, but once you do get, then get all will make a bit more sense. So the first thing that I'm going to do is get an iQueryable. I'm going to call it query of what's in the DB. So remember, DB is already defined to be whatever it is data type that we're dealing with, right? So just get all of the records basically that are in that table. Pretty much that's what this is going to do. And then I'm going to check to see if there was an includes, right? Was there an includes requirement, meaning did the user or did the calling code, whoever called this get method, would they like to include additional details? So I did say earlier that when it comes to hotel and country, instead of looking for the hotel and then getting the country ID and then calling the database again to get the country with that ID, and then that's two database calls, we could make one database call and we're getting the hotel and including the country so that it will automatically fill this property with all the corresponding country's details, right? So that's what that includes is for. So this code snippet basically says that if includes is not equal to null, so by default it's null, it's optional, you don't have to put a value. If however you choose to put a value, if it is not equal to null, then for each property in includes, I want to include to the query whatever property was asked for. So if they said country, then this for each loop is going to run once. If you have 5 foreign keys and you put all 5 of them in that includes list, then this is going to run 5 times, including each one. Pretty much that's all it's going to do. All right. So it's completely optional because there might be times when you need to include and there are times when you don't need to for speed purposes. You don't want to include all the time for one query for one bit of information when you didn't have to. So this helps us to keep the application kind of quicker than it would normally be if it included everything all the time. Then the next thing we want to do is return await query dot, and then I'm going to say as no tracking. So that's where that tracking thing comes in, because any record that is retrieved here is not being tracked. A copy is taken and it's sent into memory, sent over to the client. The database and entity framework don't really care about it. So that's why down here we say attach it. So we get that record which wasn't being tracked or being looked at, and then we say start looking at it, and just note that it has been modified. By the time it reaches here, it has been modified. So we get as no tracking, but then after that, what I really want to do is get the first or default record, and there's a first or default async. There we go. And then I can say expression. So let me explain what expression is. So expression is defined as expression function t boolean, and that's the name of the parameter. So this data type basically allows us to put in a lambda expression, because then a lambda expression would allow us to say something like q, and then the lambda arrow, and then we would say query dot something is equal to something else. So that's why it said bool, right? Whatever condition. So when we want to retrieve the one record, what is the condition that we want to use to retrieve the one record? Is it by ID? Is it by name? So this allows it to be very generic and flexible, because then we can write our different expressions based on the context, but calling one method at any given time. All right. So that's it for the next. For the get, sorry. So the next one that we have to do is the get all. All right. And get all is going to have all of that code with some tweaks along the way. So firstly, We're not going to be looking at any first or default. So let me just modify this error line. We get the query that has no tracking, and then I'm just going to make it go to list async. All right. So that's why we have that await. Once you're calling an asynchronous function, you have to precede it with await. All right. So we're returning a list. So we parse it to list as opposed to this one where we just got the first or default. Now we have the same parameter for the includes, but we have another one for order by. So I'm going to put another little snippet right after. Well, actually, I'm going to put two snippets in. So firstly, we got the query. Then I'm going to check if there was an expression. So I'm going to filter the query first before I even look at the includes, right? So I'm going to say if the expression is not equal to null, because we could be looking for a list of records, but we want to say where the country is one. You understand? Give me the list of hotels from Jamaica. So we could put in the expression to say where whatever condition is needed to specify from Jamaica. And then if it is not equal to null, meaning a condition is there, then filter the query for me, please. So query is equal to the initial query, which was all records, dot where that expression is true. Then after you've done that, because we could have had 500 and now the filter brought it down to 20, then you go ahead and put on the includes. All right. And then finally, after you put on the includes and everything, I would like you to order if necessary. So if the person passed in an order by, oh, I want it in descending, ascending, or this or that, you just say if the command came in, then query is equal to order by query. All right. So that's really all there is to the get and the get all. So we've gotten the majority of the work out of the way. We have about 2 more steps to go, and then we are done with this task. So the next thing that we want to do is create that, well, I'm going to call it unit of work, right? So we have the generic repository. Now we're going to give it the unit of work framework on top. So in iRepository, I'm just going to go ahead and add what will be another interface. So I'm just adding it and I'm calling it iUnit of work, changing this to interface. And this one is going to inherit from iDisposable. All right. And then what we're going to be defining in our unit of work would be, it's going to act like a register for every variation of the generic repository relative to the class T, right? So right now we only have 2 tables to cater for. So I'm just going to say iGeneric repository for country. For country. And include any missing reference. And I'm just going to call it countries. So different people have different naming conventions here. I call it countries. Some people would say country repository or whatever. I'm calling it countries because when I call on the unit of work, I can say this dot countries dot whatever operation I want to carry out, right? So we're going to do that also for hotels or hotel, and I'm calling the property hotels. And then we're going to have one more operation, which is a task to save. All right. So when we're carrying out all of these operations to add, to update, we're making changes to the context. But at this point, it's just staged, right? So when we say save or save changes, then it will be affected. So that is what this is for. But this is outside of the repository because if there are multiple changes to be made at a time, then all of them can be caught in one operation as opposed to making multiple calls to the database. So we have that unit of work. The next thing would be to create the concrete class. So in repository, go add class call it unit of work. And then unit of work is going to inherit from iUnit of work. And once again, include any missing references and then implement the interface. All right. So then what this is really just going to do now is say, all right, you know about countries. What should I return when you call on countries from me? What should I call on here? What does dispose do? What does save do? Those are the things that we need to define. So firstly, I'm going to include a reference to the database context, right? Similar to what we had before. And then I'm going to define my constructor, CTOR. Let me try that again. There we go. And I'm going to put in the data context. I just don't want to write it out again. So I'm just going to copy the relevant parts there and paste. There we go. So I'm initializing the data context inside of the unit of work here, and it will know that, okay, I have a copy of the data context also. So then you're probably wondering, so why do I need the data context here? And that is really because what we need to do is return an instance of the repository, but then we have to backtrack a bit. So I need two private, the same way that we would have defined them over this side as private. Let me see if I can just do this quickly. So I'm just going to take that and I'm going to define two private properties of the respective hotel and countries, but I'm going to rename them and I'm going to take off the accessor. So this is going to be countries and this one is going to be hotels. All right. So now that I have these private properties, I'm going to say down here that if the private property is empty, then return a new instance of the generic repository. So I'm just going to do that shorthand because C#9 is pretty cool. So I can just say something like countries and then question mark equals. So it's basically saying, if this is null, then what should I do? So instead of a whole if statement, right? And I'll just say, if it is null, then return an object of the generic repository of type country. And of course, based on our definition of it, you need the database context, which is why we have it injected here. So we pass in the context. All right. And then I'm basically just going to do the same thing for hotels. So this is like a register now. This is just like a Rolodex to say that all of these are potential generic repositories. Once you're in the unit of work, I have access to the countries, the hotels, and for every table that you define, you need to make sure that you put or you make representation for it in the iUnit of work as well as the unit of work. But all of what we just did with the generic repository and the iGeneric repository, we don't have to redo any of that with any other data table that we may add in the future, right? So it's just about maintaining this list and these functions to make sure that we have access to what we need right here in our unit of work register. All right. So the next thing that we need to do, or well, two more things. So I want to define dispose, and then we need to set up the save, and then we're done with this. So dispose, I'm going to kind of write dispose true. So this is just the way I do it. You may see variations of the unit of work elsewhere, but this is the way that I have come to do it for various reasons. Once again, context is king. So what I'm saying here is I'm going to call another method. So I'm going to define a method here. I'll just let Visual Studio generate a method right underneath it for that purpose. And then I'm just going to say Well, actually, now that I'm doing it, I'm just going to say right here, underscore context. So dispose is really like a garbage collector. It's just saying when I'm done or when the operations are done, please free up the memory. That's the purpose. So GC here is actually short for garbage collector. If you look at the description, garbage collector. So this is saying when dispose is called, then please dispose of the context, meaning kill any memory that the connection to the database was using, kill the connection, kill all the resources it was using, and go ahead and do what it would do by default anyway. So that is it for the dispose. The next one would be our save changes, and this one is actually pretty simple because it's really only one line, at least right now, where we say await context dot save changes async. Here's the arrow. I'm saying await, but what don't I have? I don't have the async. Once I put that there, everything is fine in the world. So let me just do a build to see if I have broken anything or if there's anything out of place. And I have a successful build, so that means I have successfully put in the code for my unit of work, at least code-wise or syntactically. Later on, we'll find out if it works or not. But right now, this is a good victory to have, and this task is done.